Hello, I'm solving problem 8 on midterm number 2. Just wrote a little stuff beforehand. So here's my free body diagram. We have mass of gravity split into cosine and sine, friction kinetic, normal force, and force of tension. And we also have in mass 2 force of tension and mass of gravity with acceleration going down and up to the right, respectively. So for mass 1, we have, we have force of tension minus mg sine theta minus friction kinetic equals m1a, and for m2 we have force of tension minus m2g equals m2 minus a, because since we have the y is positive, so since y is positive, the a is going to be negative, so negative a. And then just solving for force of tension already, force of tension equals m2a plus m2g. So we're going to go ahead and substitute that here, and we're also going to, let's do one step at a time. So substituting for force of tension, we get m2 negative a, I'm going to put that in parentheses just so we know, plus m2g minus mg sine theta minus friction kinetic equals m1a. And this was also one of the problems on my original test. I did m1a, I didn't put negative a, so here's me solving for m2 in the test. It's just ma, and then I also did mg as the positive y direction, which I mean is correct, but it's supposed to be the other way around because force of tension will be greater. So back to this, we're going to also solve for friction kinetic. Friction kinetic is equal to the normal force times the static friction, or in this case it's moving, so it is going to be the kinetic friction, sorry. So the kinetic friction here is 0.25. And we also know that the only thing in the y direction is the force normal. So Fn will equal mg cosine theta. So using that, we can do m2 negative a plus m2g minus mg sine theta minus, oh my goodness, I'm going to put this in parentheses, mg cosine theta times uk equals m1a. And now we want to get all the a's on one side. So what we're going to do is we're going to move over the m2 negative a to the other side. So this will distribute to the front, so it'll be plus m2a. So it'll be m2g minus mg sine theta. I'm sorry if the camera angle's bad. Minus mg cosine theta times uk equals m1a plus m2a. And now we're going to take out an a, so it'll be a m1 plus m2. And we're just going to divide both sides by m1 plus m2. So acceleration will equal m2g minus mg sine theta minus mg cosine theta times uk over m1 plus m2. My hand hurts. Ooh. So now I'm going to try to plug this in for us really quickly. So m2, oh boy, so we got 5 times 9.81 sine theta should be 30 degrees. It is. Are we in degrees? We are. Minus. No. Sorry. 5 times 9.81 minus mass of gravity. Sorry, I didn't label this. This should be mg1. So that'll just be 9.81 sine 30. And then this is minus 9.81 cosine 30 times uk, which is 0.25. And then we get that divided by 5 plus 1, which is 6. So it should be around 7.0035 is going to be A. So A equals 7.003 or 0.004. Now, to solve for tension force, we are going to plug everything back into the equation. So, what we're basically going to do is we're going to move these units over from the original problem. So now we're going to have force of tension equals, and we're going to add that mg sine theta because it's negative in the first problem, and we're also going to add the friction kinetic, but we know that is mg cosine theta times nu k. So I'm just going to make a note right here, mg cosine theta times nu k, and then plus m1a. And now we're just going to substitute in, and don't forget this is m1 g sine, and this is also m1 acceleration. So let's start plugging in. So mg, so we have 9.81, and then sine 30 plus, and then we're going to do 9.81 cosine 30 times nu k, which is 0.25, and then plus, it's just 1 times acceleration, so 7.003, and we're going to use the acceleration found in this equation here. So doing all of that, we should get an answer around 14.03 as our force of tension. So Ft will equal, let me read my calculator, 14. I'm trying to reach over. 14.03. This is messy because I write with my left hand. So 14.03 is our force of tension.